I'm sorry, everyone that talks in English. I've done all the research in English, so you're going to have to bear with me for a bit. As a brief introduction, Single Lab is a company that started in Silicon Valley where we do nanotechnology and AI research, and our objective is to bring nanotechnology and AI closer to people, bringing the technology back to people so you can all learn and figure out how do you want to use them. It's like when you want to build a specific form of furniture at your house, you know what you want. You know the type of furniture that you want. Doesn't mean you have to build it, but you would know exactly what you want. It's the same thing with AI. Just because you don't know how to program or you don't know all the tools that are set in place does not mean you do not know what do you want to get out of it. So first, I'm going to start by talking about the different stages of where we compute the data these days. So we have the cloud, the core, and I'm going to talk about blockchain and AI as technologies. I'm going to start with a reference that's very important, is that 20 or 30 years ago, we used to mine for minerals. Today, companies mine for data. Data is the new oil, and that means that all of your information, which some of it is private and some of it is public, is handled by companies, and is handled by basically every sort of platform where you send your data. Hence why it's very important that we don't have any sort of other privacy incidents that what recently happened with Facebook. I'm sure you're all familiar with that. So right now we're working on 3 different levels, and we have your traditional architecture, which is basically the core. We call it the core, and it's the servers that are mounted on big companies that handle big amounts of data that usually are the ones that have been built in all the architectures from the past. Now, in the recent years, ever since 2005, we have developed the cloud, which is basically the same thing as the core, but on a remote server where you can connect. Basically, Facebook's a cloud, Google's a cloud, so all your information, you send it there, the cloud processes it, and sends it back to you, sends a response. And we have this third wave of technology, which is called the edge. It's less widely known, but it's what we apply on everyday use. The edge is basically a mix of all your mobile devices, all your phones, your tablets, everything that you use to handle your data or handle your everyday life. And as we move closer to the edge, most of this computing is done on the phones. Most of this computing is done on tablets. You don't need to have an industrial-sized scientific calculator to do calculations. You can just pull up your phone and do that. So I'm going to talk about what is blockchain. Why? Because this is the architecture that supports the entirety of the rest of the platforms that we built. On a common core architecture, you have a database, which is a master copy of the record, and you usually have to access through a server through certain client-server parameters. You put your username, your password, and you access the server, but all the information is on the server itself. Whereas with blockchain, you have an entire different form of records that everyone has a copy of. So you have a copy of all the information, but you can only access this through your own hash key. You have a personal key that allows you to access that search section of the information which contains information relevant to you. Why is this important? Because that means information is not only going to be in the hands of one particular entity, it's always going to be in the hands of everyone, hence the community can regulate it as a whole, which prevents fraud and other things. Moving on, smart contracts. What are smart contracts? They work in a very similar way as regular contracts do, but they're written into code. So the code will execute itself upon the meeting of certain conditions. As you reach the milestones in the code, it will execute, it will perform the output that you have programmed it for, and hence it's transparent and it's built on the blockchain. All the community of users can access and see if the transaction was valid, again, preventing fraud. So this is a small example of how smart contracts would work. Let's say you want to buy a house. If you want to buy a house, you will go online, look for the house that you want, you will match with the seller of the house, and the contract will be written into code in such a way that the exchange happens electronically, the funds are released, the contract in itself, the legal part of it, is assigned to you, it's made digital, and it's released once the funds are transferred. And all this information happens on the cloud, or happens on a server, or happens on the blockchain, so you don't need to go and do a lot of tedious paperwork. You don't need to go and do a lot of the things that we need to do when we buy a house, which is very long. That allows for a lot of exchanges to be done in a very, very fast way, and it releases a lot of stress for government institutions or other regulating entities that will have to work with it. So where are we right now on AI? We've reached a very interesting point as of last year, 2017, where AI is performing just as well as humans, if not outperforming them, on simple tasks like pattern recognition, speech recognition, and obviously mathematical calculations have been done for years. So, fun story. Before I go into this, a fun story. In 1962, they asked a Stanford professor what would he consider a machine, intelligent machine, to be able to do. And he replied, well, an intelligent machine should be able to sell me a can of soda and give me the exact change. So as we've moved on with technology, all of these use cases have appeared and we've adopted them, and now we don't think that they're artificial intelligence. For example, a vending machine. For example, in 1993, where the first machine ever defeat the first the best chess player in the world. So as the technology moves on, we usually have a rate of adoption up in which we make it part of our lives. Hence, all the things that, for example, you may think you're not as close to machine learning as you might think, but honestly, everyone who has a smartphone can do that. If you use Alexa, Siri, or Bixby, you can teach your phone the relationships that you have with certain people. Let's say, this is my mother, this is my girlfriend, or this is my favorite place to eat, this is my favorite song. You can teach it things, and we will process that data and act accordingly. So when you ask Siri to play your favorite song, if you already taught it what it is, it'll play your favorite song every time. You don't have to tell it what it is every single time. And this brings me to the question, are our companies truly digital? Have we truly adopted these technologies? Well, this recent report by Bain and Company, done in May 2018, says that even though we have mature technologies, we have a lot of technology that has been implemented into our daily lives, we really haven't fully adopted it. Only half of the companies have adopted any sort of automation in their processes. Automation has hit big in two departments. The first one is finance, and the second one is HR, for the sorting of candidates and workplace interaction. So it's a really good thing that as we look forward, we think about these technologies that we have not adopted, because we need to take this step in order to take the next one. So I'm going to show you a little small example of where we are in AI. This is Phillips Hue. For those of you who are not familiar with Phillips Hue, it's on, can you play the video, please? It's an application of AI that basically controls your lights. Let's see if we can get the video up there. That controls your lights through your smartphone. So you'll tell them, I'm feeling down, and it'll put a certain amount of mood on the lights of the ceiling. I'm going out, it'll turn off your lights. I want to go to bed, it'll dim the lights or completely turn them off. I want to party, you'll get party lights. Yeah, seems the video's not working. Okay, we're going to skip it. You can find it on YouTube. That's good, because that's 30 seconds that I still get. And next. So yeah, I'm going to skip the next example as well, because it's another one. It's called X.AI. It's a personal assistant. You can all get it. It's a personal assistant that schedules your meetings for you. You will CC Amy at X.AI into your emails, and it'll exchange emails with the person you're trying to communicate with, setting up a time, setting up a meeting, putting it up in Google Calendar, and just sending you the invitation, saving a lot of us a lot of email time when it comes to setting up meetings. So right now, the three biggest applications, and the most common, as I was mentioning before, are Siri, Alexa, and Bixby, because all of these things learn through the data that you give them. Where's the criticism on this? And every single time you ask Bixby a question, you ask Siri a question, you are sending your data to the server is processing the request, and it's sending it back, a process that usually takes 4 to 6 seconds. And honestly, 4 to 6 seconds is not a lot of time for all of us, but when you try to do more computation on the edge, when you try to do more calculations on the spot, let's say, for example, a car that is driving itself along a highway does not have 4 to 6 seconds to process that data. Hence, the computation of that has to be done on the car itself. It cannot send a request to the server. That is known as edge computing, and that is what we're moving towards. Ideally, the model of the future would be that the devices do the computation with the data on the spot, so you don't have to send your data that might be private, might be your medical records, might be your allergies, personal information, bank information, etc., that you don't want to share with the server, because as we all know, anything you put up in the internet stays there forever. Putting it this way, there's always going to be, there's a good old saying that we have at the lab, and it's called, just because you can put Wi-Fi on it does not mean you should put Wi-Fi on it. And if any of you is a fan of the series The Big Bang Theory, and if you remember the belt buckle episode, how do you make those little flower pins attractive to men? We add Bluetooth to them. Again, just because you can add Bluetooth to them doesn't mean you should. This is a very cool application, one of the first ones that came out. It's called WordLens. WordLens was an app that you could download on your phone, and it would do translation in real time. You didn't have to take a picture or anything. It would do translation in real time. Obviously, it wasn't the best translation, but you could just fiddle around, play with the device, and just as you moved it, you'd see the translation change. Google developed their own version of this, and the downside of it is that you actually had to take a picture. Sorry, that's my alarm. I was supposed to be down by now, I'm sorry. Google actually had you take a picture, send that data to the server, and send it back. And you'll see how this difference in the model actually played a big part in it, because even though WordLens wasn't as good as Google when it came to translation, the user satisfaction was a lot higher. Why? Because they could have that translation in real time. They could play around with it. They didn't have to send the data. And again, just because you can put Wi-Fi on it does not mean, the picture's not really super clear, but this is a HestonCue. It's a cooking burner that works connected to your iPod or your tablet. So just because you can't put Wi-Fi on it does not mean you should. Where are we going right now with AI? You have, as has been mentioned before, machine learning, neural language processing, and speech and pattern recognitions. And all of these things will be applied in the office of the future in a certain way that I called fully decentralized edge computing. When we first started dealing with computers in the 60s, we had this mainframe architecture. We had these big servers that basically handled all the data, and if you wanted to know how much it was to add 2 + 5, you'd have to go to NASA and ask for their computer. We moved on to the personal computer in the 80s, which is the one that we all have at home up to these days, which allowed us to handle our own data, handle our own information, do our own Lotus 1, 2, 3, if anyone's old enough, spreadsheets before Excel came, and you could do anything in your own personal space. We moved back to centralized architecture in the cloud by 2005, because right now, all of your data is basically stored on a server. Every information that you've ever put on Facebook, what your interests are, what you like, what you don't like, when you're feeling down, all that information is stored in Facebook and Google and any other platform that you might connect your data with. And as we move forward, we're going to move into edge intelligence, where instead of connecting to the server to download, to have it send the information and have the server process the information, you're actually going to connect to the server, download the model, and do the computation on your device so you don't have to send your data. What are the potential applications that imply in the workplace? First, you have, for example, OCR, which is optical character recognition, which means the machine or the program that you program is capable of reading an email, recognizing patterns, or digitalizing a document and translating everything into information so it can execute a contract. Let's say, for example, the biggest or the simplest application that I could find was OCR applied in finance. You get a remittance payment, someone submits a scanned receipt, a scanned purchase order or something like that. Your OCR system reads it, your program thinks it and says, okay, this is from contractor A. This is the amount of payment that I have to release for contractor A for this work. Does this work match the ones that I needed completed? Yes. Is this to be paid this week? Yes. Okay, I am going to pay it. And you didn't have to do anything. And on the 10% of cases, which is the little human down there on the below, in the 10% of cases, which are usually the exception, that you send the wrong information, you send the wrong invoice, you sent the wrong payment, etc. You can solve them yourself, and that's where we're always going to be needing people to do that. It just helps with the bigger part of the workload. So right now, how are we moving towards a newer office? How are we moving towards a newer space? The Office Reimagined basically consists of 3 different things in my personal point of view. First is going to be the physical space, which I think Victor covered in a great manner, and how we apply technology to that physical space. The second one is going to be the personalization of the work experience, how each and every one works our best, and what do we need as technology tools to support that. And the third one is going to be how we manage time, because time is the critical factor that we all have the same amount of. We can all have different salaries, we can all have different ages, we can all have different houses, but we all have 86,400 seconds a day. So getting connected happens like this. Imagine you wake up in the morning, you have a meeting at 10, but suddenly you forgot you have to, your wife, your husband, they can't drop the kids at school, so you have to do it yourself. You're not going to make your 10 a.m. meeting. You actually ask your personal assistant to reschedule your meeting as it's sending emails with the other party. You drive there, you drop your kids at school, you go back and you said, you know what would be really good when I get to the office? I actually want a really, really nice warm cappuccino. So you text your coffee machine, says, please have a cappuccino ready for me when I arrive exactly in 30 minutes. My car will send you the place where I am at right now. You do that, you get there, you have your meeting. All of this allows us to stay connected to the office while not being in the office. So that means we can always move the cogs of the machine of the workplace without actually being there, and staying connected will help us get a better result out of the way we handle things. So as I move on to personalization of the work experience, we have the intelligent cloud, which is all the devices that are connected to the internet now. And you have the intelligent edge, which are or the micro devices that are going to do calculations and are going to do computations in the future. That means, for example, everyone, at least one of us, has Googled once their symptoms and found out they have cancer. Every single time. Oh, I have a whooping cough. Or like, I'm coughing and I have an itch in my arm. You have cancer. My head is dizzy and I have like blurry vision. You have cancer. You usually end up there. It's not a good thing, but the good thing about smart office analytics is that you don't have to send all the data to the server as you can do computations on the spot. You can download the model or an application or anything like that, and you can just input the things that you need to input in the application. It'll give you a result, but the data stays with you, as I've mentioned through the talk. So the other impact that will have a big resonance in the workplace will be advanced intelligence office analytics. What does this mean? This means through the analysis of the data that we produce and we agree to send, is that we're going to be able to get a better work experience. Because examples, you're measured for all the work that you do, and you find out, or the model finds out, that you're at your highest productivity on Wednesday mornings. So you have a big amount of tasks that you have to tackle during the week, but you know what? Your personal assistant emails you on Monday, you know what? You have this very, very hard task that you need to do, but since you've been at your highest productivity ever since we started working at Wednesday morning, I'm going to assign this activity you to Wednesday morning and not schedule any meetings for you. That's one application. The second application is matching teams according to their strengths. Matching, let's say there's someone that's very good, has a very good background and very strong in finance. You can match that person to someone that has very good organizational skills with someone that is very good with timelines, and finding the optimal way to build work teams, or building more work cells amongst your big work teams. And why is it important to compute on the edge? Because it has been proven in a 3-year running period that computing on the edge is actually a lot cheaper than computing on the cloud and only handling data through servers. And the reason for that is, right now, the amount of data that we're handling and the amount of energy required to handle that is very high. The amount of energy employed running the blockchain right now is actually as much as the energy needed to run the entirety of Sweden. So what's the future challenge as we move forward and as we move into this new technology or this new era of decentralized computing? Number one, data handling. How do we handle data? What data are we going to send to the servers? What data is going to be public and what data needs to remain private? Because as citizens, as people, we all have information that we don't want to share with people that aren't interested. If you have symptoms, if you're sick, you want to send that information to your doctor, but you don't want to send it to pharmaceutical companies. So it's important that we can do computations on the edge so we can preserve the integrity of that information. Number 2, network limitations. Here's why the server architecture or the cloud architecture faces its biggest challenge. I'm about to finish. Faces its biggest challenge because network limitations will tell you that you can't really send a big amount of data all the time, and you cannot receive a big amount of data all the time because you're going to saturate the network, and it's probably going to be a lot harder for you to send and receive information. Hence why the critical value is that we know exactly where to compute what information. Number 3, regulations and taxes. As companies like Uber and Airbnb take a rise and we start moving towards a more digital economy, it's important that the governments are aware of the regulations that they need to put onto these companies, on the taxes that need to be applied, if they need to be applied, in order for them to be able to be an active participant of the economy and not moving to New Zealand where they don't have to pay certain corporate taxes. Number 4, energy. Computers in itself and processors in itself are cheap, but the energy required to run them is expensive. Hence, if you are going to do the small experiment that they did last year on machine learning, they ran a big model on a big mainframe server. It took about 6 hours, and it actually spent about, I can't remember exactly how much, but it spent a lot of energy. And then one of the engineers decided, you know what, I'm not conformant with this model, so I'm going to try running it again on my laptop. Took a bit more time, and it used less than 10% of the energy. And then the challenge number 5, what about Skynet? We've all watched Terminator, and we don't want to end there. Obviously not. So the system in itself, and I think this is the key value of all the things that I wanted to talk about, is exactly that. The applications will be as efficient as we program them to, which means the value is not in knowing how to code or knowing how all these things work. The value is in finding the use cases. Finding that problem that you specifically need solved and finding the technology that will allow you to solve it. But finding the use cases where the money is going to be and where the value is going to be for everything. And the big question that everyone has in the back of their minds at some point, will AI replace me? The short answer is no. The long answer is yes, but no. As we move forward, a lot of the tasks that we usually do, sending 1,000 emails a day, clearing 200 remittance payments, what else? Doing computations, doing calculations, finding out the exact cost that we need to pay each supplier, all these tasks will be automated. But that does not mean the jobs will disappear. It means that the jobs will evolve. Because we're going to need expert people that build the use cases in order for the machines to be programmed in that way. So if you want to weld something, you're going to need a master welder to tell you how it should be welded in order to program that. If you're going to do it in finance, the same thing. You need a person to know that the balances are going to be correct. So you're going to need people to validate this information. Hence why it's critical that as we move forward, we start training people for the jobs of the future. We start telling people not to be afraid of these technologies, but rather to embrace them and figure out what they want to do with them. The value is in the use case. Thank you very much.
Impresionante, Martín.